Look around you. Look at the device in your hand, the walls of the room, the ground beneath your feet. Your senses tell you that this is the baseline of reality, solid, tangible, enduring. You are made of atoms, forged in the hearts of dying stars, bound together by electromagnetism and gravity. It feels significant. It feels absolute. But physics tells us a different story, one that is far more unsettling. Everything you can see, touch, or measure, every star in every galaxy, every planet, every cloud of gas, every human being who has ever lived, amounts to a rounding error in the cosmic equation. We have spent thousands of years studying the universe, only to discover that we are not the rule. We are the exception. When astronomers tally the contents of the cosmos, they find that ordinary matter, the protons, neutrons, and electrons that make up you and me, accounts for less than 5% of everything that exists. The remaining 95% is a silent, invisible ocean that ignores us completely. We drift on a raft of dust in a sea of nothingness, and that nothingness is not passive. It is active, it is growing, and it is hostile to the structures that allow life to exist. To understand the future, we must first confront the terrifying architecture of the present. Consider the density of the space you occupy right now. In the room where you sit, the air is thick with particles, trillions upon trillions of them interacting constantly. Now, cast your mind out to the space between the stars. If you were to take every galaxy in the observable universe, all 2 trillion of them, and compress them into a single mass, they would barely register against the sheer volume of the void. The average density of the universe is roughly 6 hydrogen atoms per cubic meter. This is a vacuum more perfect than anything we can create in a laboratory. The universe is not mostly made of things. It is mostly made of absence. For decades, we believed that this absence was simple emptiness. We were wrong. The first crack in our understanding appeared when we looked at how galaxies move. In the 1970s, astronomers analyzing the rotation of spiral galaxies encountered a physical impossibility. According to Newton and Einstein, stars at the edge of a galaxy should orbit slower than those near the dense core, just as Pluto orbits slower than Mercury. But they didn't. The outer stars were moving at breakneck speeds, fast enough that they should have been flung out into deep space. By all known laws of physics, these galaxies should have torn themselves apart billions of years ago. They didn't. They held together. Something invisible was gripping them. Something with immense mass was acting as a gravitational glue, preventing the cosmos from dissolving into a thin mist. We call this substance dark matter. It is 5 times more abundant than the matter that makes up your body. It forms massive, invisible halos around every galaxy, extending far beyond the visible starlight. It is the invisible scaffolding of the universe, the skeleton upon which the flesh of stars and planets is draped. Without it, the Milky Way would never have formed. You would not exist. But here is the truly haunting realization. Dark matter is not out there. It is right here, right now. As you listen to this, trillions of dark matter particles are streaming through your body every second. They pass through the roof of your house, through your skin, through the core of the earth, and out the other side without slowing down. They do not interact with light. They do not interact with electromagnetism. To them, you are less than a ghost. You are simply open space. We are embedded in a shadow universe that outweighs us 5 to 1, yet we can never touch it. We only know it is there because of the gravity it exerts, bending starlight from distant galaxies in a phenomenon known as gravitational lensing. We are seeing the footprint of a giant we cannot see. Yet, even dark matter is not the dominant feature of our reality. When we zoom out from the scale of individual galaxies to the scale of the entire cosmos, a pattern emerges that looks less like a star chart and more like a biological neural network. This is the cosmic web. Matter in the universe is not spread evenly, it clusters. Gravity has pulled dark matter and gas into long, thin filaments that stretch across billions of light years. These filaments are the highways of the universe, guiding the flow of gas to feed the growth of galaxies. Where these filaments intersect, we find massive galaxy clusters, dense, bright knots of matter buzzing with activity. But these clusters are rare. The vast majority of the universe is not the web itself, but the spaces in between. We call them cosmic voids. These are not merely gaps. They are abysses of a scale that the human mind struggles to comprehend. Voids are immense, spherical regions of space where galaxies are incredibly rare or entirely absent. Some of these voids span hundreds of millions of light years. To cross one at the speed of light would take longer than the entire evolutionary history of life on Earth. Light that entered a large void when the dinosaurs went extinct would still be in the middle of its journey today, traveling through absolute darkness. Take, for example, the Botas Void, often called the Great Nothing. It is a region of space nearly 330 million light-years in diameter. Statistically, a region this size should contain thousands of galaxies. In the Botas Void, we have found fewer than 60. If the Milky Way were in the center of this void, we would not have known other galaxies existed until the invention of powerful telescopes in the 1960s. For all of human history, we would have looked up and seen only our own stars, believing we were truly alone in an infinite dark. These voids dominate the volume of the universe. Imagine a bathtub filled with soap bubbles. The galaxies and stars are just the thin, iridescent film of liquid on the surface of the bubbles. The voids are the air inside, vast, expanding pockets of nothing. And this is where the story shifts from structural to existential. These voids are not static. They are growing. Gravity is the only force that can resist the expansion of the universe. In the dense filaments and clusters, gravity is strong enough to hold things together. But inside the voids, matter is too sparse. Gravity is too weak. There is nothing to fight back against the expansion of space. As a result, the voids are expanding faster than the rest of the universe. They are swelling, pushing the filaments of the cosmic web thinner and thinner. Matter is draining out of the voids, flowing gravitationally toward the dense clusters, while the empty regions grow larger, colder, and more dominant. This creates a runaway effect. The emptier a region becomes, the less gravity it has. The less gravity it has, the faster it expands. The universe is effectively hollowed out from the inside. We are witnessing a cosmic segregation. Matter is retreating into isolated islands, huddled together against the encroaching dark, while the oceans of emptiness between us widen every second. This expansion is driven by the most mysterious and dominant force in the cosmos: dark energy. Unlike dark matter, which pulls things together, dark energy pushes them apart. It accounts for nearly 70% of the total energy budget of the universe. It is not a substance. It appears to be a property of space itself. This means that as space expands, it does not dilute. If you double the size of a box of air, the air gets thinner. But if you double a volume of space, you get twice as much dark energy. It is a self-reinforcing nightmare. The more the universe expands, the more dark energy there is to push it apart faster. We are living in a temporary era of balance. The cosmic web is still connected. We can still see distant galaxy clusters. We can still map the structure of the cosmos, but the scaffolding is being stretched to its breaking point. The filaments are thinning. The voids are consuming the map. We are not slowly filling the universe with life and structure. The universe is actively isolating us. This is the first uncomfortable truth of the cosmos. Emptiness is the default state. Structure is a fleeting anomaly. We cling to our small island of matter, surrounded by a dark matter halo we cannot see, drifting on the edge of a void that is expanding faster than we can imagine. The universe is biased toward separation, and as we will see, this separation is not just spatial, it is causal. The growing emptiness is doing more than just pushing galaxies apart. It is erasing the possibility of contact, communication, and memory. The silence we hear when we look up at the stars is not just a lack of noise. It is a preview of the ultimate fate that awaits everything. The darkness is not just waiting, it is accelerating. For most of human history, the universe was assumed to be eternal and unchanging. The stars were fixed points of light, pinned against a velvet backdrop that had existed forever and would exist forever. Space itself was seen as a passive stage, a static theater where the drama of existence unfolded. That assumption was wrong. In the 20th century, we discovered that the stage is not static, it is stretching. And this stretching is not merely moving things around. It is fundamentally altering the limits of what is possible, creating a boundary beyond which reality itself fades into absolute silence. This boundary is known as the cosmic event horizon. To understand this horizon, we must grapple with the speed limit of the universe. Light travels at a finite speed, roughly 300,000 kilometers per second. Nothing can move faster. But space itself is not bound by this rule. Space can expand at any speed it chooses. At this very moment, the distance between us and the far reaches of the cosmos is growing. For galaxies that are close to us, gravity is strong enough to overcome this expansion. But for galaxies far away, the expansion of space dominates. There is a specific distance, currently sitting roughly 16 billion light-years from Earth, where the recession velocity of space equals the speed of light. Beyond this line, space is expanding faster than light can travel through it. This creates a terrifying one-way door. Any photon emitted by a galaxy beyond this horizon will never reach us. It can travel for 1 billion years or 1 trillion years, but it will never close the gap. The space between us and the photon is being created faster than the photon can cross it. It is like running on a treadmill that is accelerating. Eventually, you are swept backward, no matter how fast you run. Every single day, thousands of galaxies cross this horizon. As they do, they are effectively deleted from our observable reality. They do not cease to exist. They still have stars, planets, and perhaps even civilizations. But they are now causally disconnected from us. No signal they send can ever reach us. No signal we send can ever reach them. They have slipped off the edge of the world. This leads to a profound and melancholic realization. The observable universe is shrinking. Not in physical size, it is growing larger every second, but in terms of access. We are losing the ability to see the cosmos. The pool of information available to us is evaporating. If we could look at the universe billions of years in the past, we would see a sky teeming with galaxies, all within our reach. But we have arrived late to the party. The expansion has already carried vast portions of the cosmos beyond the horizon, erasing the evidence of their existence from our sky. Project this process forward into the deep future, and the implications become chilling. In roughly 100 billion years, every galaxy outside our own local group will have crossed the horizon. The expansion will have swept them all away. the night sky will change drastically. Today, with powerful telescopes, we can see billions of other galaxies. In that distant future, astronomers will look out and see nothing but absolute darkness surrounding our own merged galaxy. These future observers will have no way of knowing that a wider universe ever existed. The cosmic background radiation, the afterglow of the Big Bang, will have faded to undetectability. The distant galaxies will be gone. The evidence for the Big Bang, for expansion, for the vastness of the cosmos, will have been erased. These future scientists will construct models of the universe that are completely wrong, yet perfectly consistent with their observations. They will believe they are alone in a static, dark void, the only island of matter in existence. They will be wrong, but they will have no way to know it. The universe is not just hiding its contents, it is actively erasing its own history. This erasure of information brings us to one of the most haunting questions in all of science, a question that connects the physical expansion of space to the potential for life. The Fermi paradox. The universe is old, nearly 14 billion years. It is vast, containing trillions of planets. The ingredients for life are everywhere. By all statistical logic, the cosmos should be teeming with civilizations. We should see their megastructures, hear their radio signals, detect the waste heat of their industries. Yet, when we turn our telescopes to the sky, we find only silence. The great silence. Where is everybody? Many solutions have been proposed. Perhaps life is rare. Perhaps intelligence is a fleeting accident. Perhaps civilizations destroy themselves with nuclear fire or biological engineering before they can leave their homeworlds. But the accelerating expansion of the universe offers a different, darker possibility. Perhaps the silence is not biological, but geometrical. Civilizations are not just separated by distance. They are separated by time and the expansion of space. For two civilizations to make contact, they must exist in the same light cone, a region of space-time where signals can be exchanged. But as we have seen, that region is shrinking relative to the size of the universe. Imagine a civilization arising in a distant galaxy 5 billion years ago. They build powerful transmitters and send a message of peace into the void. That message travels at the speed of light. But while the message is in transit, the space between their galaxy and ours expands. The journey stretches from millions of years to billions. By the time the signal reaches the position where our galaxy should be, we have moved. Or worse, the expansion has stretched the wavelength of their signal so severely that it becomes indistinguishable from the background noise of the universe. The signal arrives, but it is a whisper too faint to be heard. It is possible that the universe is full of voices, all shouting into the void. But the void is stretching their voices into silence before they can reach anyone else. We may be surrounded by ghosts, civilizations that lived, flourished, and died, their signals forever racing through an expanding dark that will never let them land. This concept reframes the great filter. The filter might not be a specific event that destroys civilizations, like war or plague. The filter might be the universe itself. The window of opportunity for contact is finite. As dark energy accelerates the expansion, while the number of galaxies we can communicate with drops, we are being placed into solitary confinement. This isolation is structural. It is baked into the geometry of space-time. It suggests that the default state of intelligent life is solitude. We are born on a rock, we look up, we wonder if we are alone, and the universe ensures that we never find an answer. The distances are too great, and they are growing too fast. Even if we developed ships capable of near-light speed travel, we could never catch up to the galaxies that have crossed the horizon. They are lost to us forever. there is a specific kind of horror in this realization. It is not the horror of a monster in the dark. It is the horror of the dark itself. It is the realization that the universe is indifferent to our desire for connection. It allows complexity to arise, allows minds to wake up and ask questions, but then pulls the answers away faster than we can reach them. The cosmic web is being torn apart. The filaments that connect galaxy clusters are stretching thin. Eventually, they will snap. When they do, the clusters will become true islands. The Milky Way and its few neighbors, Andromeda and the Magellanic Clouds, will merge into a single supergalaxy. Gravity will hold this local island together, but everything else will recede. We will be left drifting in a sea of expanding nothingness that grows exponentially larger every second. The causal connections that bind the universe together are being severed. We are witnessing the fragmentation of reality. The universe is breaking into pieces, and those pieces are drifting away from one another, never to interact again. This is the era of isolation. We are currently living in the last golden age of astronomy, the last moment where we can see the full scale of the cosmos. We are the witnesses to a dying connectivity. Every photon we capture from a distant galaxy is a message from a past that is already gone, a ghost image of a world that has likely already passed beyond the horizon. And as the external universe fades, a new process begins to dominate. The isolation does not just affect the space between galaxies. It dictates the future of energy, of heat, and of life itself. Once the galaxies are separated, once the supply of fresh gas from the cosmic web is cut off, the clock starts ticking toward the final phase of existence. The islands of matter will be left to fend for themselves with a finite amount of fuel in a universe that is growing colder and darker by the moment. The silence we hear now is just the beginning. The true silence, the silence of exhaustion, is yet to come. The universe does not end with a bang. It does not end in fire or in a sudden cataclysmic tear that rips the fabric of reality apart. It ends in silence. It ends with a long, slow fade into the dark. Right now, we are living in what astrophysicists call the stelliferous era, the age of stars. It is a time of light, heat, and chemistry. It is the only time in the history of the cosmos when life as we know it is possible. But this era is an anomaly. It is a brief flash of brilliance in a timeline dominated by cold and decay. Stars are not eternal engines. They are finite stockpiles of fuel. Every second, the sun consumes 600 million tons of hydrogen, fusing it into helium and releasing the energy that sustains our planet. But that hydrogen is a limited resource. Across the universe, the rate of star formation has already peaked and is crashing downward. The great stellar nurseries are running dry. The universe was once a roaring bonfire. Now, it is a bed of dying embers. In roughly 1 trillion years, the last new star will be born. After that, the universe will never again see the ignition of a fresh sun. The lights will go out, one by one. The massive blue giants will die first, exploding in violent supernovae. Then the sun-like stars will swell and collapse into white dwarfs. The last holdouts will be the red dwarfs, tiny stars that sip their fuel so slowly they can burn for trillions of years. But eventually, even they will exhaust their reserves. When the last red dwarf flickers and dies, the universe will enter the degenerate era. This is the age of corpses. The cosmos will be populated not by living stars, but by stellar remnants, white dwarfs, neutron stars, and black holes. The galaxies we see today, those spiral masterpieces of light and color, will become graveyards. They will be dark, rotating disks of dead matter, drifting through an expanding void that has grown so large that other galaxies have long since disappeared from view. In this era, the universe will be cold, but not yet dead. Occasionally, two white dwarfs might collide, sparking a brief, lonely supernova that illuminates the darkness for a few weeks before fading back into black. But these events will be rare. For the most part, the universe will be a place of shadow. And then, matter itself will begin to fail. Many physicists believe that the proton, the fundamental building block of atomic nuclei, is not stable. Over timescales that defy human comprehension, protons may decay. If this hypothesis is true, then the solid matter that makes up the stellar remnants will slowly dissolve. The white dwarfs and neutron stars will rot from the inside out, turning into a fine mist of subatomic particles and radiation. The physical structures of the universe will simply evaporate. This leaves only the black holes. For an unimaginably long time, a period known as the black hole era, these gravitational monsters will be the sole inheritors of the cosmos. They will sweep through the empty galaxies, consuming any stray matter that remains. But even they are not immortal. As Stephen Hawking theorized, black holes leak energy. Through a quantum process known as Hawking radiation, they slowly lose mass. This process is agonizingly slow. A black hole with the mass of our sun would take 10 to the power of 67 years to evaporate. Supermassive black holes, the kind that anchor the centers of galaxies, will last far longer. But time is the one thing the universe has in abundance. One by one, the black holes will shrink. As they reach the end of their lives, they will release their stored energy in a final, blinding flash of gamma rays, a last scream into the void, before vanishing completely. When the final black hole evaporates, the universe will cross the ultimate threshold. Welcome to the dark era. This is the final state of reality. The universe will be a sea of photons, neutrinos, and electrons, bespread so thin that they may never interact with one another again. The density of the universe will drop to effectively zero. Temperature will plunge to just a fraction of a degree above absolute zero. This is heat death. The term is misleading. It sounds like a fiery inferno. In thermodynamics, heat refers to the transfer of energy. Heat death is not an explosion of heat, but the death of heat itself. It is the state of maximum entropy. Entropy is a measure of disorder, but more importantly, it is a measure of equilibrium. Life, machines, and stars all operate on differences. A steam engine works because the fire is hot and the water is cool. A battery works because one side has a charge and the other doesn't. You are alive right now because your body is warmer than the air around it, allowing energy to flow. In the dark era, there are no differences. Everything is the same temperature. Everything is the same density. The universe becomes a perfectly flat, featureless ocean. No energy can flow because there is nowhere for it to go. No work can be done. No thought can be formed. No time can be measured because nothing changes. It is the end of history. In this eternal tomb, a strange and terrifying phenomenon might occur. Quantum mechanics tells us that even in a perfect vacuum, energy fluctuates. Particles pop in and out of existence. Given an infinite amount of time, these random fluctuations can produce strange results. If you wait long enough, long after the stars are gone and the black holes have faded, random quantum fluctuations could theoretically assemble atoms into structures. Most of these will be chaotic uselessness. But purely by chance, a fluctuation could arrange matter into a brain. A fully formed, conscious mind, complete with false memories of a life that never happened. Physicists call these Boltzmann brains. Such a mind would exist for a microsecond, hallucinating a reality, perhaps thinking it is sitting in a room watching a video about the end of the universe before dissolving back into the chaos. It is a disturbing thought. In an eternal, empty universe, these lonely, hallucinating minds might vastly outnumber the real biological observers who ever lived. The final inhabitants of reality might be mad ghosts born from the static of the void. But eventually, even the potential for these fluctuations may fade as the expansion of the universe stretches space so fast that particles are ripped apart before they can interact. The universe will become truly, absolutely empty. This is the ultimate erasure of memory. We often think of the past as something permanent. We believe that even if we die, our actions, our history, the fact that we existed, remains written in the fabric of reality. But heat death suggests otherwise. When the universe reaches maximum entropy, the information that describes the past is scrambled beyond recovery. There will be no record that Earth existed, no trace of the pyramids, the moon landing, or the wars we fought. No trace of the stars that burned or the galaxies that spun. The universe will not just be empty, it will be amnesiac. It will have forgotten that it ever contained anything at all. This realization, that the universe is headed toward a state of absolute oblivion, is terrifying, but it also clarifies the value of the present. We are living in the Goldilocks moment of eternity. We are here during the brief, impossibly rare interval where the universe is rich with structure, energy, and possibility. We are the beneficiaries of a cosmic accident existing in the narrow window between the fiery chaos of the Big Bang and the freezing silence of the long fade. The fact that you can look up and see stars is a privilege. The fact that you can think, feel, and wonder is a temporary gift given to us by a universe that is slowly winding down. We are the universe's way of knowing itself before it goes to sleep forever. The emptiness that waits at the end of time is not a judgment. It is simply the nature of the machine. The universe is a process of dispersion. It started as a single point of infinite density, and it will end as an infinite expanse of zero density, which we are the friction in between. We are the sparks flying off the gears as the machine grinds toward a halt. So, when you look at the night sky, do not just see the stars as distant lights. See them as the dying campfires of a species huddled against the dark. We are alone, we are temporary, and we are drifting apart. But for this moment, we are here. And in a universe destined for nothingness, that is the only thing that matters. If this journey through the end of time has left you staring into the void, remember that the void is also staring into you. Hit the like button to mark your existence in the digital record before the entropy takes us all, and subscribe for more transmissions from the edge of reality.